All right, good morning, everyone. Today, we are going to review for that Unit E test. Actually, yep, got that. So here's some skills, and I know it's 8 pages, but some of it is just pages to remind you of some stuff. But one thing you're going to be responsible to know is how to go from a fractional exponent to a radical. Remember, this is the same thing as the 4th root of 81. And then what number times itself 4 times is 81? That'd be 3. If you have a variable like x to the 1/5, all you need to know is how to write that as a radical. That's the 5th root of x to the 1. Technically, you don't need the 1, but you're welcome to put it there. Negative 64 to the 2/3. That's the same thing as the cube root of negative 64 squared. And then what number times itself 3 times is negative 64? That'd be negative 4. So then I get negative 4 squared, which is 16. You can just type that in the calculator also, and it'll spit out 16. I can show you. See? Negative 64 to the 2/3, 16. You just can't do that with variables. How to go from a radical to an exponent? That's 4, that's a 2. So this is the same thing as x to the 4/2. But 4 divided by 2 is 2. So that gets x squared. Okay. I'll let you do this one yourself. 3x to the 2/5. Actually, we can do that real fast. That's the same thing as the square root of 196, and 14 times 14 is 196. Here, 3x to the 2/5, the 2/5 only applies to the x. If this was in parentheses, it would apply to both. So this is the 5th root of x squared, so I get 3 5th root of x squared, or 3 5th root of x squared. Both of those are the same thing. You get to decide. Do I want to do the radical first, then the power, or power then radical? So that's one of the first skills we learned, and one skill you will be responsible to show. The next skill is rationalizing. So to rationalize a denominator containing 2 terms with 1 or more square roots, you multiply the numerator and denominator by the conjugate. So I'll let you do this one yourself. So the conjugate of this would be 3 minus 4 squared of 3. And I am going to have to move a little faster today. This packet's kind of long, so I may not be able to describe every step, but I could at least kind of walk you through most of them. Here, I take 5 times 3, 5 times 4 squared of 3. That's 15 minus 20 square root of 3. Here I distribute. I take 3 times 3, 3 times negative 4 squared of 3, 4 squared of 3 times 3, those cancel, and then 4 squared of 3 times negative 4 squared of 3. So because the middle term cancels, because they're conjugates, I really just need to do 3 times 3 is 9, and then 4 squared of 3 times negative 4 squared of 3, that'd be negative 16 square root of 9. This is 16 times 3. That'd be 9 minus 16 times 3. If you do 9 minus 16 times 3, you get negative 39. You then look at these three numbers and you try to divide them all by the same number. 39. 3 goes into 39. 13 goes into 39, but 3 and 13 do not go in these two. Now we normally just take out a negative. And so what I mean by that is we'll divide them all by a negative to get this negative out of the denominator. So that'd be negative 15 plus 20 square root of 3 divided by positive 39. I divided all of these by negative. You may see the answer written like this or like this. Both I have seen. All right. So that is called rationalizing. Make sure you can do this one. Next, do you know how to reduce radicals, including one with the negative exponent? I'll let you do 9. I'll do 5. Okay, so 5, let's think about, well, let's get rid of this negative 9. So remember, this is the same thing as the 5th root of negative 64 y to the 7th divided by, and this x to the negative 9, I could drop the negative down to the bottom of the fraction to get rid of the negative, and it's still going to be 5th root. So I'm kind of doing 2 steps in one. So this is going to be the 5th root of x to the 9. So I need to reduce negative 64. So I'm going to take negative 64 and break it down. Actually, let's just do 64. And remember that the 5th root of a negative is going to be negative. Okay, so 64, that's 2 times 32, 2 times 16, 2 times 8, wow, 2 times 4, 2 times 2. So I'm looking for 5 2's. I have 1, 2, 3, 4, 5. Okay. So that would be, you could bring out the negative, and then you have 1, 2, 3, 4, 5 2's. You're looking for 5 2's. So that would be negative 2 with this 2 left over. I always like double checking my work, especially on video. And so what I did was I typed in the 5th root of negative 64, negative 2.29. And then I typed in what I thought it was, negative 2 times the 5th root of 2, and that's negative 2.29. Just wanted to check my decimal, and I did forget the 5 here, because that's still the 5th root. Now here, y to the 7th. If you think about y to the 7th, if you write down y 5 times, or 7 times, how many y's do you have that are the, how many sets of 5 do you have for y's? You have 1, 2, 3, 4, 5. So 1 y comes out, y squared stays inside. So these two together, we just said the 5th root of negative 64 is negative 2, 5 square root of 2. Negative 2, 5th root of 2, I should say. And then 1 y comes out because we're looking for 5 y's. 2y stay inside. I know I'm going through this kind of fast on purpose. Here, I have x to the 9th. How many x's do I have that are a set of 5? I have one set. So 1x comes out, leaving 4 inside. And then technically, we need to rationalize the denominator. I'm going to stop here for sake of time, but I'm pretty sure you have one like this on the test that you don't have to rationalize. How do you multiply radicals? Well, you just distribute. So you take square root of 5 times 2 square root of 5, and make 2 times 5, or 2 times square root of 25. I'll show the work. And then square root of 5 times minus 1. That's minus 1 square root of 5. I'm going too fast on any of this. Remember, I'll post this, and you could watch the video later and slow it down and watch it again and again if you need to. And then I'll take negative 5 times 2 square root of 5. That's negative 10 square root of 5. And then negative 5 times negative 1. That's plus 5. Here, that's 2 times 5. That's 10. Negative 1 square root of 5s and negative 10 square root of 5s. That's negative 11 square root of 5s. Plus 5. 10 plus 5 is 15. We get 15 minus 11 square root of 5. I'll let you do 16 yourself. All right, can you describe the transformations? So can you look at this and talk about how it changes from the parent? Remember, anytime there's a negative 2 in the radical, that's going to shift it to the right. So that shifts to the right 2 units. Let me use a better word, translate. 2 units to the right. What does the 1 do? The 1 translates it 1 unit up. I have a green pen. Easier to write in. Translates 1 unit up. So if this is a negative, it goes right. If this is positive, it goes left. If this is positive, it goes up. If it's negative, it goes down. Now, I'll let you do this one yourself. The only thing different is this negative out front. What does the negative do? I'll do that first step for you, just in case you forgot. The negative reflects it over the x-axis. It flips it over. Negative reflects over the x-axis. Now the graph, I'll let you do the graph yourself, but the vertex starts at 2, 1. So you go over here, and I'm going to do a rough sketch. So it starts at 2, 1. And then because it's positive, and I'm just going to do a rough sketch. If you want the exact sketch, you could go type it in Desmos, but it's going to look something like this. And again, that's just very, very rough. Whereas this one, the vertex is at negative. Oh, and I forgot something important. Cube root also does the same on both sides, right? Again, this is a rough sketch. Where this one starts at negative 1, 3. Why am I not drawing the exact graph? For the sake of time. So now this one's going to go up, and this one's going to go down. Again, you could get the exact graph from Desmos. How do you get a 3? Again, you type in NTHROOT, and that'll let you put a 3 up there as the index. Everything I just said is summarized on this page. What happens? What does each thing do? I'll let you read through that yourself. Here are some examples of shifting and the notation that goes with that. Again, I'll let you read that yourself. The whole page was basically just notes. Let's talk about domain and range. And I'm going to do this one a little bit different. You will have access to Desmos. So first you need to know the vertex. The vertex is at -1, -2. -1, -2. And again, this is going to be a rough sketch, but you could go to Desmos to get the more exact. So this is positive. It's going to go up. Something like that. Not exactly. Something like that. And so when I talk about the domain and range, left to right, the smallest this could be is -1. The biggest it could be is anything. So it starts at -1 and goes forever. So domain, I'm going to say x is bigger than or equal to -1. Notice it came from this number because -1 plus 1 is 0. Square root of 0 is okay. But if I were to put in a -2, -2 plus 1 is -1. You can't take the square root of a negative number in the real number system. What's the range up and down? The smallest number is -2, and it goes up forever. So my range is going to be y is bigger than or equal to -2. And again, this sketch, this is just a sketch. I don't have time to go through and plot every exact point today. Here, this starts at 2, -3. So I go to 2, -3. The negative, instead of going like that, it's going to go like this. Again, this is very rough. So domain is going to be 2 and up. Range up and down, 1, 2, 3. It's going to be -3 and less. So y is less than or equal to -3. Okay. And just to show you, we could type the same thing on Desmos. There it is. So in case you don't know how to graph, there's the vertex right there. It's 2 and up, -3 and less. All right. Inverses. I'll let you graph on Desmos. You'll have access to Desmos. But to find the inverse, remember, if it's a g of x, you change it to a y. And then you swap the x and the y. I need to make sure I remember that the radical is over both of these. Kind of hard to see there. So it'd be y plus 5 over 4. Square root of all that. So then I could break that up into the square root of y plus 5 divided by the square root of 4. Square root of 4 is 2. Okay. And I'm trying to get y by itself. So then I would square both sides. Which I just did 2 steps I didn't need to do. Oh well. Oh, square both sides. So now I get x squared equals the square root and the square cancel. The 2 changes back to a 4. I could have just squared it from here. I wasn't thinking. And then multiply both sides by 4. Subtract 5 from both sides. And then switch it back to the inverse, g of x. Remember, I put a negative to symbolize inverse, equals 4x squared minus 5. Now, as to the graph, I'll let you use Desmos to graph. But remember, there is a way to check our work. And I'm definitely going to check our work here. So my original function was g of x equals the square root of x. Let me go ahead and put divide. X plus 5 divided by 4. And then I think the inverse. And to find the inverse, you can go g of y equals x. Well, I forgot what you type in there now. Does this have to be an F? I can't remember. F of x equals 1. There's a way to type that in to get the inverse, and it's not coming to my brain. Do you guys remember? No? I'll have to look in one of my old previous videos, but there's a way to get the inverse. I can't remember what the notation is here. That was f of y equals x. Or is it x? Yeah, that looks like the inverse. Okay, I figured it out. And then I think the inverse is 4x squared minus 5. Okay. So technically on this one, we don't want the left side. We don't want the left side here. So we're going to specify that x needs to be bigger than or equal to 0. Because we don't want the right side of the inverse. We just want, well, we don't want the left side. We just want the right side. Okay. All right. Next one. I'll let you do 10 yourself. Now we are to the part that should be fresh in your brain. Radical equations. I picked these radical equations on purpose. I hope you go through and work each of them out. There's 1, 2, 3, 4, 5, 6 of them. There's no way I could do all 6. I will show you the one that kids seem to struggle with the most. That's all I have time for. And it's one like this. You have a square root equal x plus 5. To undo square root, you square both sides. Square root and square cancel. And then if you take x plus 5 times x plus 5 and you distribute, you get x squared plus 10x plus 25. So if I write that down twice, I do x times x times 5, 5 times x, 5 times 5, I get this. I'm solving for a quadratic. I move everything over. Subtract 21x. 10 minus 21 is negative 11. Subtract 1, I get 24. I then factor. What multiplies to 24 but adds to negative 11? Negative 8 and negative 3. So then this becomes 0 is x minus 8, x minus 3. And I think my answers are 8 or 3. Now, you can plug back in and just make sure that none of them are extraneous, or you could solve all of these using Desmos if you would like. It's just better if you know how to do the algebra also. But on the district assessment, you have access to Desmos. And so let's say, let me go graph this in Desmos and just see what we get. Bye-bye, bye-bye. So the left side, I had square root of 21x plus 1. The right side of my equation was just x plus 5. Where do you intersect? I think at 8 and 3. Ooh, looks good. Now, that's not the answer, 3 comma 8. I know that's super confusing. The solution is not the y value, it's the x value. So looking at that, I get 3, ignore the 8. So I get 3, and then here I get 8. So I get 8, and I get 3 are my solutions. If I were to plug 3 and 8 back into the equation, I would get the same thing on both sides. Okay. Looking at the time, looks like I could do this one for you. I'll do Desmos real fast. I'll type this in, and I'll type that in. Negative 3. Now, Desmos doesn't like b, so I'm going to put x. X plus 15 raised to the 3/2 minus 1. I don't think it likes b's. And then when I type in negative 82, it doesn't like that either. I have to put y equals negative 82. And so I'm going to go way down here, and I see they intersect at one spot at negative 6. There's my solution, negative 6. X equals negative 6. If I were to solve this algebraically, I would get negative 6, which it won't take long. That's negative 3, b plus 15 to the 3/2, add 1 to both sides, that's negative 81. Divide both sides by negative 3. It's 27. And then I'm going to write this as square root of b plus 15 raised to the 3rd is 27. Take the 3rd root of both sides. But the 3rd root of 27 is 3. Square both sides. Subtract 15. And I get negative 6. Same answer. I just got, and I should change this to a b, not x. We didn't have an x. Okay. All right. One final thing. Not every function has a solution. So this is f of x. So let's say that this equaled 6. So if I had 6 equal to 3 square root of x plus 5, what is the solution? Would there be a solution? Yes. I can subtract 5 from both sides. Divide both sides by 3. Square both sides. And that'd be 1/9. So yes, there would be a solution. But what if I had, say, -4? Would there be a solution? And I'll let you finish the rest, but I subtract 5, divide by 3. You cannot take a square root of a number and get back a negative, so this would be no real solution. Why? Because you can't take the square root of a number and get back a negative number. Okay. So I'll let you finish the rest. I kind of made it on purpose where I could show you one and then you could do one yourself. I highly encourage that you look through this review, study it before you take that district assessment. Other than that, that's all I have. Schedule that test. I'll see you later. Bye-bye.